So we are having an infinite loop here, but what can we do about it? How else can I compare it to null? Like this? Haha, cyberpunk ads. Like this. I think we can do it like this, right? Instead of calling equals, because we mess it up completely. I think. And of course, same here. Yeah. What happens now? Uh, um, not. Not. So if I am not null, I compare myself to other. And if other is null and I'm not null, then that's fine. Okay. I am not sure if this is a better approach with that one. I'm not sure if I like it more. No, I don't like it more. It's too long of a line. It messes my readability. Though it's less code, but I don't like it. Okay, so we finally got the comparison work. If I go here, do it again. Nah, I don't like it. It's too much going on. It's not a simple return for one value. It's also a check. So I don't want to have a check within a check with what was it, a ternary operator. Nah, I prefer it this way. Okay, so that one works, and now we can compare, do our cloning and see if it works. So shallow clone, we say person 2 is person 1 clone. Assert are equal person 1 person 2. Yeah. B-Day, I forgot to move that one. Oh crap. Okay, so the test worked, it seems. We cloned it successfully. And let's do a more fancy cloning. I mean, let's make a test which fails with more fancy cloning. So we create a person, father, Thomas the Great. His birthday, unfortunately or fortunately, will be a bit different. 1981, let's say. 19 years old, he got a baby. B-Day father, B-Day mother. Mother. And this will be 82 and 4. And father next to father. And mother next to mother. And you will go at the end. So Jaina, just Jaina, B-Day, this one and this one. All right, and we say we create Thomas, and he has a mother and a father. And what happens? We write a test if deep copy works. It did. It did, right? It did. But did it? Clone person deep. Okay, that's fine. But I want one more. Clone person deep after original change. Okay, so I change original and I expect them not to be equal. So I will change person 1. Father, let's say height to be 183.3 f. And now I compare. And it shouldn't be equal. But it will be equal. Would you use this design when you're working, for example, on an object and it is not saved yet? What did you mean by an object and not saved? What kind of an object? Are we still talking about person? If let's say I was working with accounts. So I just demonstrated that cloning failed because we create shallow clone. What we need to do is to create a deep clone. So our copy needs to clone accordingly those things. What's wrong? Really? Really? Private set. I think it works. Okay. So one more thing that is quite interesting. You see, I'm accessing a private setter from an instance, but I can access it because I'm inside the same class. So it was always confusing for me, but that's possible. Mother. So we clone our related stuff too. And if I run the test now, it worked. So this is how cloning works in C#, and we just created a deep clone. With these three things, we tested 3 cases. We tested if cloning shallow works, if cloning deep works, and if cloning deep after change really works. I mean, if we clone the stuff that is nested and if we are independent from the stuff that is nested. So that's how prototype pattern is implemented, can be implemented in C#. Would you like more patterns to be done? I will scroll up a bit. Scroll up a bit. Clones, okay, command pattern, object pooling. I guess we can do command pattern. Fast. Okay. So what commands could we do? What would you like about command pattern? Because I think it's fairly simple. Like, really simple. Do you have any, like, idea? What would you like to do? Well, we could... Well, I mean, it's really simple. Have you done any commands? Have you used commands? Or you just... Why were you curious about it? What was curious? What were you curious about? I wonder. Never used it, that's why. Okay. In that case, let's implement a TV, shall we? A TV. So we have a television class, and we have public void accept accept command, I guess. So TV will be like command executor. Now I wonder, why do I need to execute it in the context of TV? So we have a command. Well, what do we want? We want, by pressing some button, a TV to react. Okay, TV will be an abstraction for some display. It might not even be an actual TV, but it will, by command execute, it will do something. Thinking. Execute command. What does it mean? Execute command. Execute command for TV. Signal. Okay. So execute command will produce some sort of signal, I guess. And signal will have not good, not good. Well, let's make it more stupid. So TV will be simply a bunch of properties like volume, like current channel. It's int, of course. What else? Is on. Super simple. And commands. Turn on TV. So the thing about our commands will be that we have execute, we pass in television, we say TV, and we say TV is on true. And at the same time, we say console. Actually, I won't. That's all it does. Yeah, that's all it does. Yeah, that's all it does. Okay, so we have this. Let's create an interface. Namespace. Interface. Seems good. Why would you prefer this over having it in the class television though? You will see it soon. It's not the best example, but you'll see soon. ITV command. And execute television TV. Yeah, ITV command. Yep. And let's create a bunch of those. ITV command, so turn on TV, turn off TV, false. Volume up, volume down. And let's say that will be enough. So we have those commands. Switch channel, one more. This one will be a bit different because ITV command, because we pass input. So we pass in channel as a command state. So we don't write a channel command for each channel, but rather just one. But we will keep the channel inside, read only, of course. And we say implement and channel TV, current channel is channel. Now this might seem like a waste of time, and it probably is, but Imagine if logic was more complex. Then it would make sense having it in a command. Another reason why I might want a command. I will not test it here because it's hard to test it that way. I will test it here. Let's create a new class. TV test. TV simulation. So I say public void run. So I guess I will create it here. Var TV is new TV. I need a reference. And I say television. And I say var flow new ITV command array like this. I think I can do. So it will be a bunch of commands. Okay. Volume down. And let's create a bunch of those. Okay. So we create a new list of commands. New, I forgot. So we create a TV, we create a bunch of commands that we're gonna simulate. And now the interesting part about it is that we can treat them all as one. Execute them all as one and do something in between for each of them. So we can, I don't know, have a TV run a command actually, still. And TV will be like, on top of all it has, it will have command runner, I guess. So we inject this one. And what can a command runner do? Run commands. So when TV is created, we inject a runner for commands. And it will have RFID. And yeah, TV, command runner, and remote controller, it would be nice. So when we create a remote controller, it will be linked with a command runner. So maybe I don't need RFID. Command runner. I wanted to link it through the RFID, but maybe not. Okay, remote controller, public remote controller, I command runner. So we create a link between the two. Okay. Turn on TV. How do I link it? I guess. Turn on TV. Something like that. What could I do? What could I do? Remote controller should have buttons. Each button creates a command which sends that to the runner. Well, lots of rewriting. Damn it. Nah, I think this is I'll ignore remote controller. It's a next. We're simulating stuff, so we can imagine that our program here is a remote controller. So a remote controller has a list of TV commands. Here we say we don't have it yet, so I'll create it here. TV command runner. And implement. And I say console write line starting command sending signal. For CMD. Minus. And we say CMD execute. Now this is problematic. How can I solve it? Well, let's get an event added too then. Event command signal received. Okay. So, all right. Signal received. So I shoot this. Invoke this new no CMD. So when I run a command, I say that I ran it, and then I send the signal to TV that TV will subscribe to. So I'm wondering if there's a specific reason why I wouldn't simply create commands class containing static methods for all commands. I'm showing you, soon you'll see. Right. So here I say a runner signal received. Yep. And here I say on signal received, command execute. That's like that. This. Okay. On signal received, execute command. So what I did now is I simulated what it means to fire a signal to a TV and for a TV to accept the signal and execute the signal within it. So if I go to my runner, which is here, as you can see, I fire an event which will be transmitted to the TV when I need to execute command. Now, why is this potentially beautiful, as Julian asked? Because I can do stuff in between for all of those commands in a unified way. Because I can all run them all in one unified way. That's why it's quite attractive. So that's one thing. A command itself will be much more than just setting a property. So it's complex logic, and if I had multiple, like if I had to define them all and if they were all complex, I would clutter one class and make it big. With commands, I can separate them in different files, so it's easier to manage. What else of the things that I should note? It is really well designed because it binds to buttons very well. Like, for example, VPF, it uses commands to bind actions to buttons. So they understand that you don't have to implement all actions in the same class. They can be in their own class because they tend to be complex. Same with commands. And why would I ever want to have a separate command and a separate file other than the reasons already said? Because I can mix them. Some remote controllers might not have volume. Some remote controllers might have no specific channel selection. So it really depends on what it is and what you have. So, god damn it. Oh, okay. Wasn't that bad. New TV command runner. And all we do here is... Wait, what do I do? I got mixed a bit. Command runner runs command execute, does something with TV. All right, so we have command runner, which does something. So I think all I need to do is call this iRemote controller, and it makes sense then. Where's rename? And run TV command. You don't run it. Send TV command. Signal TV command. Signal sent. Signal sent. So on signal received, I execute a command that I got from a remote controller. iRemote controller. And this will be TV remote controller. And TV simulation. Here I will keep it, but I will link it. TV remote. And I pass it here. So I create those two. And now I for each them and I say signal CMD. Signal is sent. Look. Well, I mean, sent or send, you mean? It is, I mean, this is the action itself of sending a signal. It is being sent, whatever, I agree. So I signal an event to a TV, and a TV accordingly does what it should. So let's see what happens. Let's run it. In the end, let's do console.readline and say simula new TV simulation and simula run. Why is it? Okay. See what happens. So you can see we send the signal to turn on TV. We send the signal, send the signal. Now let's, when we send the actual signal and when we run it, TV on signal execute. I guess I will. I really don't want to, but I will say something in the console just to see the effect. say it was off, it was on, volume down. Volume up. And channel. Okay. So if I go here, it fails to build. But now you can see, like, we execute commands in the same way. So we send signal, complete signal, and in between we run the command. We run the command, we run the command, we run the command. So the benefit of this, if we look back at the code, in between, okay, not here. Actually, even there, in between doing the commands or just running them all together, we have a unified way of executing them. And the complex logic, which is fairly simple in our case, but that might not be the case. So we can split it nicely. So running in a unified way, different actions, is something that we can achieve with commands. And I think this is pretty close to real TV. Like, you have a decoupled remote controller from the TV. You signal something to TV, it accepts the signal and runs whatever was transferred with the signal to it. So, do you have any questions? I shall send the project. I will try to create. Can I create a GitHub from here? Team Explorer. I will after this. So that's it for today and good night.